About 300 million years ago, Earth was blanketed in swampy forests filled with giant lycopsids, horsetails, and seedless vascular plants. These coal-forming wetlands dominated the Carboniferous landscape for millions of years. But as the Permian period began, those lush forests rapidly declined and eventually vanished. What happened? The root cause was a massive environmental transformation driven by plate tectonics. Continents collided and fused into a single supercontinent, Pangaea. This enormous landmass had vast interiors, far from the sea. With fewer coastal regions and long distances from oceanic moisture, the global climate shifted. Rainfall became seasonal and irregular. Large central regions of Pangaea grew drier and more arid. At the same time, carbon dioxide levels began to drop, largely due to the burial of massive amounts of organic carbon from those same swamp forests. This cooling effect lowered global temperatures in the late Carboniferous. Later, carbon dioxide began to rise again in the early Permian, but by then, the climate had already become drier and more extreme. Oxygen levels also fell from their peak of over 30% in the Carboniferous to more typical levels in the Permian. While this didn't directly affect rainfall, it did reduce fire resistance and made life harder for oxygen-hungry organisms. The swamp plants, especially lycopsids, were not built for change. They needed constant moisture, shallow water, and spore-based reproduction. As wetlands dried up and climates turned seasonal, these plants collapsed. Their disappearance paved the way for new drought-resistant species, especially seed-bearing plants that could survive dry spells and spread more effectively. The fall of the great swamp forests wasn't just ecological collapse. It was a major evolutionary shift from a wet, oxygen-rich planet to a drier, more complex world shaped by resilience and adaptation.